Now sometimes what's going to happen is you're going to see a trinomial and your brain is going to be on factoring mode. And so what happens in something like this is you see this one and you immediately go like this. This isn't wrong, but you can sometimes make your life a lot more difficult by doing this. Why is it difficult? Because the ones with a number in front are harder. Right? Now I have to do 3x and x, which isn't too hard. That's the only way to get 3x squared. But now with 18, when you see 18, can you see that it could be 1 and 18, 3 and 6, 9 and 2? And so you choose one of those numbers to start with and have to check if they work. If you chose 1 and 18, it's going to be bad. Because if I go 1 and 18, I'll have 54 and 1. Does that ever make 15? No. If I switch them and do 18 and 1 here, does 3 and 18 ever make 15? Yes, if you subtract. Unfortunately, in this one, it's going to be one that you have to add. So you might think you've got it. So oh yes, it works. 3 and 18 make, so I go 18 and 1, and plus and plus. And I multiply it out, and what do I find? It doesn't work. So it can get frustrating because it does still take a lot of thinking and a bit of time to find the one that works. Because after we rule out 18 and 1, then you might go to 9 and 2, and then to 6 and 3. And if you happen to choose the factor of 18 that works last, you've had to do a lot of mental math before finding the right answer. But there are sometimes, remember the factoring we started with by saying, hey, look at all three terms. What do they have in common? They're all divisible by 3. I heard you, Claire. And so if you factor out the 3 first, life becomes easier. What's going to be first? An x squared, and then a plus 5x, and then a plus 6. And we can continue now and say, now this one looks like a trinomial still. Maybe I can factor it. Maybe it's not possible. Sometimes we're done after taking out the common factor. But we have to check. Can I factor this? Well, if I could, can you see that that would have to be x and x? Those are my first numbers. Is there a way to get plus 5 and 6? Okay, yes. You could do it with 3 and 2 plus and plus. I'm going to underline the 6 because those 2 and 3 still make 6. I quickly multiply it out in my head. Does it work to be x squared plus 5x plus 6? Yes. So this is factored completely. So you ask yourself, what happens, Mr. JR, if I know that you're telling I should check for a common factor first, but what happens if I didn't? Right? What happens if I found one that worked? If I went directly to here and I found, oh, 3x plus 9 times x plus 2 works. Check it. 3x times x, 3x squared. My blue ones and my red one. And finally, my purple one. Do you see the purple one? 9 times 2 makes 18. Does my blue 6x plus 9x make 15x? Yeah, it does. So would I be wrong if I did it this way? No. This is perfectly right, but it's not done yet either. Because in one of these two factors, the first one, do you see that there's a common factor between 3 and 9? So if you did this first, you would have to then factor the 3 out of the first one. And that would be factored completely. This is easier. What's in the blue is easier. Factoring out the common factor first is easier. What's in black is harder to factor at the beginning, And then harder to remember, I should still look for a common factor to factor out. Yes? Trinomial.
Yeah. We could just take away the number and then solve it like that.
If it has a common factor, you can factor the common factor out first. But there's not, sometimes let's say this is 3x squared plus 14x next. Then the 14 can't pull a 3 out of that. Then you would have to do the more difficult way. Okay? So 6x squared plus 20x minus 6. I think this sort of gets to your question. Can we pull out a 6? No. What can we pull out at 2? So we do that first. Pull out the 2, leaving us with 3x squared plus 10x minus 8. Now we might be done, or it might be that this is possible to factor further. If it is possible to factor further, can you see that this has to be 3x and x? Now it's your job. Look at the 8. 8 is 4 and 2 or 1 and 8. Try and figure out if there's one that works to give you the 10. Yes, there are. 4 here and 2 there. The 4 makes my outside 12, my inside 2. Does that make sense when I talk about my outside? No? So when I'm talking about FOIL, right, the outside are those two. The inside are those two. And I've always color-coded by making the outside blue and the inside red. Can you see that my outside is 12 now, 12x, and my inside is 2x? This part right here, which we always wrote in black, is always the outside and the inside combined. So we had the 12 and 2. Can that make 10? Yes, but only if the 12 is positive. So I need to make sure that my 12 is positive, and my 2 has to be negative. 12 minus 2 makes 10. And so now this one is factored completely. The third one here, 5x squared y plus 35xy plus 60y. First of all, this doesn't look like one of our trinomials at all that we factored. So sometimes this makes it easier because this probably triggers you to think, oh, I have to take out a common factor. What's in common in all of those? 5y. So I would be left with x squared plus 7x plus 60 divided by 5? 12. And then we have to ask ourselves, is this done or could this be done further? If it could be done further, this would have to be x and x. 12, anything with 12, so that our outside and inside makes 7. 3 and 4. Plus and plus. Quickly multiply it out to check. Yes, it works. So this one is factored completely.